All right, good morning, folks. We're going to talk about series circuits today. Um, this is the first of two major parts of this unit. After we finish this, we will do parallel circuits, the other type, and then fill in some gaps in between. But the test, which will be next Friday, is going to consist mainly of being able to talk about series and parallel circuits. So we'll talk about series today. Hopefully, the lab that you did yesterday will help guide us with this. And if you haven't done that lab yet, you need to go ahead and do so because it will help you with solving these problems. All right, so with series circuits, we see that each component here, when things are set up in series, each component is connected one after the other, and there's no splitting of the current. So if we follow the current from the battery, from one end of the battery back to the other, we're going to see just one path, and there's no splitting of the current. When we have parallel circuits, we're going to see how the current actually splits. So here's an example of a 9-volt battery connected in series with two 30 ohm resistors. All right, so we have the battery symbol that we talked about yesterday, and then the two resistor symbols, and we just connect them with wires. And notice it's always in a nice, simple geometric shape. All right, and so what we're going to learn today is we're going to use our findings from our lab to see if we can figure out everything we need to know about the current, voltage, and resistance in the whole circuit. We know some things, we're going to try to find others. All right, so first thing we want to talk about, because in order to measure these things, we need to have voltmeters and ammeters. We talked about this yesterday, where a voltmeter measures voltage and an ammeter measures current. And we talked a little bit about where they're supposed to be, and we're going to do that right now. So we know that the voltmeter, we'll start with ammeter, sorry. We know that an ammeter is placed in series with the circuit. We make sure that the current goes through it. All right, so we come down here and we look. So if we wanted to measure let's say we wanted to measure the current coming out of this first resistor, we'll call this resistor number 1, resistor number 2. So we want to find the current coming out of that resistor, we would just place the ammeter, make it part of the circuit, and then we would draw the circle with the A. Okay. Typically, we would really clear out part of that. We wouldn't just draw it over the circuit, but it's okay to do that. So that would be our ammeter. Right, and then our voltmeters would be placed outside of the circuit, parallel to the circuit, in other words, on either side of what we were measuring. All right, so if I wanted to measure the voltage across the second resistor, I would draw one line here, and then my voltmeter would just go on either side. And these lines represent the two little voltage probes that you saw in the lab. One is the red, one is the black. You put red one on one side, black one on the other, and you record it. And when you do that, if you get a negative number, just ignore the negative number. Because if you flip around the probes, you'll get a positive number. All right, and so if I wanted to measure the voltage of the battery, I'd just go over here and do the same thing. And that would measure the voltage over here. If I wanted to measure the current in the battery, I might put my ammeter right here. Right, and hopefully you notice something about the currents everywhere in a series circuit, and we'll be able to talk about that here in a minute. All right, so let's talk about those rules. Okay, so what did we see from the lab? All right, hopefully the easiest one to see is that the current was the same everywhere. Right, the current coming out of the battery was equal to the current going into resistor 1, which was equal to going into resistor 2, and so on. Right, so we say that I total, and when we say total, that's the stuff that's coming out of the battery because that's the source. So the total current is equal to the current through resistor 1 is equal to the current through resistor 2. And if I had more resistors, it would be resistor 3 and resistor 4 and resistor 5 and so on. But the current is the same everywhere. All right, so that makes things fairly easy, right? So if I know the current through any part of the circuit, I know the current everywhere. All right. Second, the voltage across the resistors. If you notice, hopefully, they add up to the voltage of the battery. So if I have like a 10-volt battery, and voltage across one resistor is 3, then the voltage across the other one would have to be 7 because they have to add up to be 10. Right? And so the way we would write that is V total. Again, voltage of the battery. V total always means the battery is equal to the voltage across resistor 1 plus the voltage across resistor 2, and so on if I have multiple voltages. You have to remember that voltage is the same thing as potential difference, which is very closely related to energy. Right? So it takes a certain amount of energy to push the current through each resistor. So if it takes 3 volts to push, if it takes 3 volts to push through one, then it's going to take 7 to push through the other. Okay, but they're all going to add up to be the battery voltage. Right? And then the resistance of the circuit, each resistor has its own individual resistance, but we can look at the total resistance of the circuit, reduce it down as if it was just a single resistor. The total resistance then is simply just the sum of each individual resistor. All right, so that's really easy. So if I need to find the total resistance of the circuit, I just add up the individual resistors. And we're assuming here that the wires don't have any resistance. Even though technically they have a little bit, we're going to ignore that. All right, so basically, these are the 3 rules. Rule number 1, rule number 2, rule number 3. Combine that with Ohm's law that we learned in the last unit, V equals I times R. We can calculate just about everything we need to calculate about a series circuit. Right? And later on this week, we're going to learn 3 rules for parallel circuits as well. They're similar, but they are different enough to be completely different, but they're similar enough to where there's a common thread to them. Okay, but we're going to focus again just on series today. All right, so let's look at a couple of examples, and then you're going to practice them. All right, so a 12-volt battery is placed in series with a 10 ohm resistor and a 20 ohm resistor, and we're going to fill in the following blanks. Okay, this is called analyzing the circuit. All right, this is called analyzing the circuit, meaning that we find everything we can about the voltage, current, and resistance. All right, so the first thing we're going to do is we're going to actually draw the circuit. So there's my battery, there's my first resistor, there's my second resistor, and we'll come back around. And then we'll label it. We know this is 10 volts. No, sorry, not 10 volts. This is 12 volts. This is 10 ohms. This would be R1. And then R2 is going to be 20. Whoops, sorry about that. R2 is equal to 20 ohms. All right, and so now it's just a matter of going through each one. Let's fill in the blanks that we know. If we know the battery, we know the battery is 12 volts. We know that V total is 12 volts. Right? What else do we know? Right? I don't know the total resistance or the total current. That's not given to me, at least. I don't know the voltage 1 or voltage 2, but I do know resistors 1 and resistance 2. So I know this is 10 ohms and this is 20 ohms. Right, so now it's just a matter of using our rules that we just had and using Ohm's law. All right, so we can start off with, well, we know that rule number 3 tells me that R total is equal to R1 plus R2. Right, so R total is going to be 10 plus 20, which is equal to 30 ohms. So I can write that 30 ohms here. That's from rule number 3. All right, now the steps that you're going to do for this is going to depend on what you know. So you have to kind of stay pretty flexible with working with some of these. All right, I'm going to change color. All right, so now we can see here that we know V total and R total. So if we remember that V equals I times R, V total is going to equal to I total times R total. All right. Well, V total is 12 equals I total times 30. And so we can figure out very quickly that I total is just going to be 12 divided by 30. which is 0.4 amperes. So that's 0.4 amps. All right, so now we work our way along. Can I do Ohm's law for either of the other two? No, because I don't know V2 or I2 or V1 or I1. But remember, rule number 2 said that I total equals I1, which was equal to I2. So we know then that I1 is 0.4 and I2 is 0.4 because they're all the same. So with series circuits, once you find one, you can fill in the rest of it. Right? And then finally, if we know I1 and R1, can I find V1? It's very simple. I'm going to change colors again. We know that V1 is equal to I1 times R1. So V1 is going to be 0.4 times 10, or 4 volts. Okay, and we can also say that V2 is equal to I2 times R2, which is going to be 0.4 times 20. Sorry, that was supposed to be 20. Ran out of room, which is going to be 8 volts. And we can check ourselves because we also know that V total is supposed to be equal to V1 plus V2. 4 plus 8 is 12. And it checks. Okay, so the process here, this is like solving little puzzles, but you're going to use the 3 rules that we learned back here. We learned these 3 rules, and we'll use Ohm's law of V equals I times R, and we'll be able to solve for any of these types of problems. So let's look at one more. All right, so an unknown battery is placed in series with a 10 ohm resistor and a 20 ohm resistor, and an ammeter placed after the 20 ohm resistor reads 0.2 ohms. So basically, again, we're going to have a battery, V equals, we don't know. So we got our 2 resistors. So this is 10 ohms. This is 20 ohms. And it says the ammeter placed after the 20 ohm resistor, somewhere over here. So this ammeter, the ammeter reads, I2 equal to 0.2 amps. All right, so I can put that 0.2 amps because that's the one that's coming out of the 20 ohm resistor. Because if I want to call this resistor 1, I'm going to call this resistor 2. Okay. Now, what else do we? We know this is 10 ohms, R1. We know R2 is 20 ohms. We don't know V total this time, but we do know I2, right? And if we know I2, doesn't that mean we know, right? If we know I2, that's going to be equal to that's going to be equal to, let's try that all over again. I2 is going to be equal to I1, which is going to be equal to I total. So this is going to be 0.2. This is going to be 0.2. And at this point, right, we know that we can add these two together, right? We know that R total is equal to R1 plus R2 is equal to, so that's going to be equal to 10 plus 20. So that's going to be 30 ohms. And now we can just use V equals I times R for each of these, right? So V2 is going to be I2 times R2, which is going to be 0.2 times 20, or 4 volts. Right? V1 is going to be 0.2 times 10, or 2 volts. Times 10, or 2 volts. Right? And V total is going to be 0.2 times 30, or 6 volts. All right, so there's 4 volts, 2 volts, 6 volts. And again, we can check ourselves. The total voltage should equal to the sum of these two, which they do. Okay, so what I want you all to do is take this, go ahead and look at the practice problems. We're going to spend some time tomorrow. I'm going to meet with the whole class tomorrow and work through one or two series circuit problems just to make sure that we're comfortable with them. I want you to practice these, and then we'll move on to parallel. The series circuits are a little bit easier than the parallel, but if we get a good grasp on this, and the parallels, not too bad. All right, so y'all practice these and have a great day.